is the highest mountain in all of Africa and one of the most iconic mountains in the world. For decades, Mount Kilimanjaro has attracted hikers, adventurers, and romantics alike. Popular in books and movies, Ernest Hemingway described it as wide as all the world, great, high, and unbelievably white in the sun.
Kilimanjaro is a snow-covered mountain, 19,710 feet high.
When people talk about the snows of Kilimanjaro, they're talking about its glaciers, immense sheets of slowly moving ice formed from layer upon layer of compacted snow, accumulating for hundreds, even thousands of years.
To be a glacier, ice has to move, ice in motion. To move, you have to have pressure from accumulating snow on top.
And like other glaciers on Earth, the ones on Kilimanjaro are in serious trouble.
We're losing glaciers around the planet. It doesn't matter whether you're in the tropics of the Andes in South America or on Kilimanjaro or any of the glaciers in Africa or over in Papua, Indonesia, the ice is disappearing.
For the past 30 years, Dr. Lonnie Thompson of Ohio State University has been collecting ice core samples from glaciers all over the globe. His ice core collection, stored in a freezer kept at 30 degrees below zero, is one of the largest in the world.
The oldest records we have to date are from the Glia ice cap in the western Kunlun Mountains in China. That record goes back over 750,000 years from a mountain range.
One of our best records is what's recorded in the ice as far as getting us a perspective on many of the variables that cause climate change.
And this is the second core to bedrock on Kilimanjaro.
We can look at the composition of the world's atmosphere in the past, looking at the air trapped in the bubbles. So you have little capsules of the air of the past.
Analyzing the ice cores can reveal many things about the Earth's climate from past thousands of years.
So you can measure CO2, methane, nitrous oxide, everything we're concerned about in today's world, only you can get these long-term histories of these, how they've varied in the past.
Through the many layers in the ice cores, no layer has shown more impact from climate change than the most recent years.
There's really no analog in this long archive of where we are today. And of course, we're really concerned about where we're going to be in less than 100 years if we continue on our current path.
If the ice and snow on Kilimanjaro were to disappear, the economy of Tanzanian communities that rely on the mountain for tourism and natural resources could be in serious jeopardy. Elsewhere in the world, the disappearance of glaciers could have serious impacts on communities that rely on them for drinking water, hydroelectric power, irrigation, and many other needs. Scientists also worry that the vanishing of glaciers worldwide is a signal of other, more drastic climate changes to come.
They are the canaries in the coal mine for ice. And I think the fact that they're all telling us the same story, to me, is what's really of concern.
To better understand how climate change is impacting the mechanics of glaciers, it's important to look at how glaciers melt.
Most glaciers around the world today experience a negative mass balance of the glacier as a whole.
Dr. Douglas Hardy of UMass Amherst has been to Mount Kilimanjaro a total of 13 times and continues to go once a year, measuring the decline of its glaciers. From his camp near the summit, Hardy sets up weather stations at different points along the glaciers that measure everything from air temperature to solar reflection.
Working at 6,000 meters is very difficult. It's very unpleasant much of the time. And it's exhausting to spend an entire day chipping into the ice or walking and drilling holes into the glacier to reposition stakes on the glacier, climbing the tower. It's exhausting.
At the summit, air temperatures stay below freezing, but because the air is so thin, the sun's solar radiation is more intense, and that has a huge impact on the ice.
We've got a tremendous amount of radiation coming from the sun, energy coming from the sun because we're at high altitude, we're above much of the atmosphere.
As the solar radiation penetrates the glaciers, it causes the ice to melt, turning the solid ice into a liquid. In some cases, the radiation is so intense that the ice is vaporized, a process called sublimation.
Sublimation is nothing more than evaporation going, in the case where we go from a solid to a vapor.
Precipitation is one of the keys to preventing these glaciers from melting and sublimating. The more snow falls on the mountain, the more the glaciers are protected from solar radiation, which reflects off the white surface of the snow.
Kilimanjaro precipitation is always in the form of snow, and every time it snows, it brightens the surface of the glacier.
If there is less snow cover, the glaciers are more exposed to solar radiation and thus more subject to melting and sublimation. Tanzania has seen a lack of precipitation in the form of a drought, resulting in less snow cover on Kilimanjaro. The drought, some scientists believe, could be the result of climate change over a much larger area, the Indian Ocean.
We know that the heat content in the Indian Ocean has been increasing as a result of warming of the atmosphere. We know that the sea surface temperatures have been changing, and we know that precipitation over much of Tanzania, East Africa, has been decreasing.
Climate is everything. It's temperature, it's precipitation, it's radiation, it's cloudiness. All of those variables are out there.
All of which are driving the glaciers of Kilimanjaro and others around the world to disappear, sometimes into thin air.